formula book. Let's go to the formula book, because in exams, you'll be given this formula book.
Okay.
So the first thing you do when you have an integration like that, you can look in this formula book. I'll copy this and put on that page so you can see it. Because you're allowed to look in the formula book. I'll put the formula on the side there.
Mm-hmm.
So we want to integrate those things. I will divide them into 3 groups. The first group is the one in pink. The second is the one in green. The next one is the one in yellow. Now, we want to integrate 3 sec squared, the one in pink. Is there any formula there that you can use?
Yeah. To integrate sec x, there's the before last one where it turns into
So to
wait, no.
integrate sec squared, you get,
No, wait, there's the first one, sec x squared kx goes
yes,
to 1 over k.
so that's correct. So to integrate 3, 3 is just a number. So this 3 is a number, the 3 stays the same. You don't change the 3. Keep the 3 the same. Integral of sec squared, it becomes tan x. So sec squared x, integrate that, it becomes tan x. So you just copy that from the formula book. It becomes tan x. So we have done the pink one. Let's go to the green. 5 over x is the same as 5 times 1 over x. So 5 is just a number. So the 5 will stay the same. 1 over x. When you integrate 1 over x, what does that give you?
X to the power of 0, no?
No, when you integrate 1x, that becomes x to the minus. When you integrate
Oh,
1x, you get
oh,
ln
it
x.
becomes ln x, yeah.
Yes, 1 over x becomes ln x. That's another one which is not in the formula book, but you just need to memorize that. And then the
Wait.
next one, the last one, the one in yellow.
Yeah, wait, for the green one, why does it become 5 ln x and not just ln 5? Like, why do we have to separate the two, the
5
green
over,
part?
that's a good question. 5 over x is the same as 5 times 1 over x. You happy with that?
Yeah.
5 is the same as 1 over x. This 5 is just a number. So we keep the number outside. We don't integrate the number. You keep the number. So we're integrating 1 over x. When you integrate 1 over x, you get ln x. That's
Okay.
why it does it that way. So you separate it, it becomes 5 times 1 over x, and then you integrate that, it becomes. Now the last one, 2 over x squared, the one in yellow. You can separate it as 2 times 1 over x squared. So I'm dealing with the one in yellow. It's like 2 times 1 over x squared. But to integrate 1 over x squared, you can write it as 2 times x to the minus 2. You take the x squared to the top. Does that make sense?
Mm-hmm.
And then when you integrate now, the formula for integrate, add 1 to the power, divide by the new power. The power is minus 2. So we add 1 to it, it becomes minus 1, and divide by minus 1. So that becomes 2 times x to the minus 1 over minus 1. So 2 times x to the minus 1 over minus 1, which will be minus 2x to the minus 1. And you can bring the x to the minus 1 underneath. It becomes minus 2 over x. So the last one, it would be
Minus 2 over x
minus 2 over x. And then there's something we do when we finish integrating,
plus c.
plus c, the constant of integration. So that's how you've done that question 1a. It's divided into 3 things. We separate them and then integrate each one at a time, and use the formula book to help you to get the formula for integral of sec squared And then use the idea that integral of 1 over x, which you must memorize, that integral of 1 over x is called ln x. And they put the ln x in that absolute sign because they only want the positive values. So integral of 1 over x is ln x. You just have to memorize that. You can prove it to show that it works, but they're wasting your time. They don't ask you to prove it in exams. So just memorize that and the other formula, and that'll help you with integration. Integration is one of the longest part of A-level mathematics. So if you really understand integration, you'll go a long way to do a lot of questions.